Hello everybody, especially my subscribers and everybody who is following my videos. And I want to say that this video is especially dedicated to one of my students, Tomasz H. So let's start with the explanation. In today's video, I want to go through the topic solving the logarithmic equations of different types, which basically means that there you can find like 4 or 5 different types of the logarithmic equations, and the first type is, let's say, like called the common property, or how you can find or identify that the logarithmic equation is in this type, is that all the logarithms in the logarithmic equation have the same basis, and based on this fact, it means that you use really the law that a logarithm base a of u, if it is equal to logarithm base a of v, and this statement is true if and only if u is equal to v. So as it is called the type of logarithms with the same basis, the critical thing is that on the left side of the equation you have the logarithm of the base a, and on the right side you have the same base of the logarithm, which is in this case the base a. The second type of logarithmic equation could be called, or we can say that it is like to solve the composite logarithms, which means that you will find some equation which is like composite of 1, 2, 3, maybe sometimes more, but you won't find quite often more than 3 composite, and it is because we are solving and trying to solve the equation where the function on the left side of the equation is a composite function, and it consists of let's say 2 or 3 logarithms. I will explain later on. The third type of the logarithmic equation could be called like logarithms with different bases, which for example could be something like a logarithm base of base a of u plus logarithm base b of v is equal to logarithm base c of let's say w. You will see how to solve such an equation. And the last type of algorithmic equation I'm gonna explain today, like really in this complex video about these 4 types of logarithmic equations, is gonna be about substitution. Okay, so now let's start with all of these 4 types of the logarithmic equations, and let me explain in more details how to, and how it works in general. I will use the Desmos program or application for sketching the graphs of the functions, because basically when we are solving any equation, it means that we are solving the equation, for example, of the equation of kind of g of f of x is equal to g of x, and what we are basically looking for, as you already probably know from the very easiest linear equation, that one of the linear function is represented as the line like this, and the second one is represented like this, which means the first line is the representation of the function f of x, and the second line is the representation of the function g of x. And basically, when you are solving such an equation, you are looking for the intercept, and especially for the coordinate of x of the point of the intercept of these two functions. Okay, let's go a little bit further, and let's start with the next explanation, what basically we will use in all of these exercises, or in all of these 4 equations we will be solving. As we already know, the exponential function a to the power x and its inverse function is logarithm base a of x. We already know that to solve any exponential function, like very or common task is, for example, we were solving something like 2 to the power of x plus 1 is equal to the power of 3, and we were using the rule that if the basis, which in this case is number 2, the base is 2, then if this statement is true or must be true, this is if and only if, as the bases are the same, the exponents must be equal, which means that we really came from the exponential equation to the very simple and very easy linear equation. When we solved, we found the x's, and that these were our roots, or in this case this was one root of the equation. When we are solving any kind of equations, basically the good manner, and sometimes it is really good to know what is the domain of the function of f of x, which is the domain of the function on the left side of the equation, and then the domain of the function on the right side of the equation. But sometimes, as you will see and I will explain, it's easier, and it's quite complex task to find the domain of the function of on the right side of the equation. So before, or you better do the check at the very end of the equation than finding the domain of the function. So basically, if you are not asked to find the domain of the function, then you simply, in a lot of cases, if it's complex equation, you solve the equation and then you do the check. Okay, so this was like pre-intro of this video where all of this comes from, and now let's do apply and let's solve our first equation. So our first equation would be to use the type of the equation, and how to find out that this is kind of type of the equation. We'll be solving the equation log x take away log 2x minus 5 is equal to log 3. The first thing I want to notice here is that you will not find any basis here, because as we already know, these logarithms are called like common logarithms, which means and which indicates that the base of all of these 3 logarithms is base of number 10. Before I'll start to solve this equation, I really want to explain the idea what is behind that. On the left side we have something like function f of x, and we are looking where these two functions f of x and g of x will intersect. For this I will use the Desmos program, and I'm gonna show you what I mean by this. Let me just take the screenshot from the Desmos, and as you can see, the solution of this function, which can be found graphically, would mean first of all to sketch the graph of f of x, which is log x minus log of 2x minus 5, which is the blue line here, okay, and the second function, which is defined as g of x, which is a log of 3 with the base of 10, of course. And as you probably know, and I will write it again later on, is the constant function, which is represented here in this graph by the black line. And to find the solution of this equation, it basically means to find the intercept of these two functions, blue and green function. And as you can see, the intercept or the coordinate of the intercept point is equal to number 3. So let's prove this. As we already can see from the graphical representation, it is really gonna be number 3. So let me solve this equation, and solving the equation where the bases are the same or equal, it would mean that we will use the laws of the logarithms, they were explained in the previous videos. So basically you can write the left side of the equation as logarithm x over 2x take away 5 is equal to log 3. So as we already said before, it means if the bases are the same, then the arguments must equal. So this is true if and only if the expression x over 2x take away 5 is equal to 3. So this one is really easy to solve. We do multiply both sides by the expression of 2x take away 5. Then it's gonna be changed to the very easy linear equation. X is equal to 6x minus 15. Now we do apply the operation like take away. I'm sorry, it's not times 2, but it's take away 6x, which means negative 5x is equal to negative 15. So multiply by negative 1 over 5, which means x is equal to 3. As you can remember from our graph, which is again here, you can see that really the solution should be equal to 3. And by solving this task algebraically, we came to the same result. The only thing we have to do now is to do the check over this equation, which would mean that we will find out what the log of 3 take away log of blah 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 is equal to log of 3. So let me just find the domain of all these functions to explain. As we already know, the domain of any logarithmic function, it requires that the argument is greater than 0. So the condition is x is greater than 0 and 2x minus 5 is greater than 0. Which would mean that x is greater than 0 is the interval from 0 to the infinity. We already know from the logic and sets theory that AND logical operator means intercept with the next interval, but before I'll write the interval, it means I have to solve this inequality, linear inequality. So 2x is greater than 5 because of the operation plus 5. So it means x is greater than 5 over 2. So this is gonna be intercept of the interval 5 over 2 to the infinity, and the result of this intersection means that this is gonna be interval 5 over 2 to the infinity, and as x is equal to 3, x belongs to the interval from 5 over 2 to the infinity. So our root is really okay. So the conclusion is that the set of the roots is one element set, and it is number 3, which is correct. Let me just try to do the check, which would mean that if we do the check for this equation, we have to find the value of the left side for x being 3, and it would mean then the left side is equal to log 3 minus log 2 times 3 minus 5. So the left side is log 3 minus log 6 minus 5, which is log 1, and 10 to the power of 0 is equal to 1. So this is really equal to log 3, okay? Because log 3 is log 3, but log, this is like the definition of the logarithm, log base 10, I will write it here, of 1 is equal to. So the question is, what is it equal to? And the answer is 0, because from the definition there comes 10 to the power of 0, 10 to the power of 0 is equal to 1, which is correct, okay? So log 1 is really equal to 0, which means that the left side for x being 3 is equal to log 3, or logarithm 3. And as you probably can see, the right side of our equation for x being 3 is equal to log 3, and as you can see, the left side is equal to right side. So our conclusion, x being 3, is really the correct answer. So this was the first type of logarithmic equation, explained in a lot of details and construction or connections with all the knowledges you have from the previous lessons. Now let me go through the second example, which means that we have something like composite logarithms, which is kind of logarithms that they don't have the same basis, but this is kind of composite function, because my equation looks like this: logarithm base of 2 of logarithm 1 over 4 base 1 over 4 of logarithm base 9 of x, and as you can see, this is my composite logarithm, is equal to -1. Again, I want to show you what it means if you would use the program or application called Desmos to sketch the graph of the function on the left side and the function on the right side, which of course on the right side is the constant function. So let me just show you these two graphs of these two functions, and as you will see, okay, I'm gonna do this a little bit smaller, but I want this time to show you couple of more details in this graph. That's why I'm gonna use the bigger one. So basically, to solve this equation, it means that you are looking for the intercept of the function on the left side, which is represented by the blue line in this exercise or in this screenshot from the functions, and the green line is represented by the constant function when y is equal to -1, and you are looking for this intercept, as you can see in this picture which I pasted here. The intercept is in x being equal to 3. Okay, so this is the graphical representation of this logarithmic equation. Now let's solve this algebraically. What is needed here and what is important is to get rid of all the logarithms based on the definition of the logarithm, which says that log base of a of u is equal v if and only if a to the power of v is equal to u. Okay, this is what we gonna use in when we will solve this equation. Okay, so let's start with this one. Basically, 2 to the power of -1 must be equal to all of the argument of our function, which would then lead to the equation log base 1/4 of log 9 of x is equal to 2 to the power of -1. As we already know, this is equal, the right side of this equation is equal to 1/2. Okay, now we do the same thing as we did before. It would mean base to the 1/2 must be equal to the argument of the function, which is this one. Okay, and this means that our equation is gonna look like this: log base 9 of x is equal to 1/4 to the power of 1/2, which we already know from the exponents that this is gonna be the square root of 1/4. Okay, and it means it's gonna be 1/2. So now we have the very simple equation like this one, and it means logarithm base 9 of x is equal to 1/2, which means again we do apply the same rule or the definition of the logarithm, which says x is equal 9 to the power of 1/2, which is square root of 9, which is equal to number 3. So x is equal to number 3. Let me just remind you graphical representation of this equation, which is this one, and it means our solution is really correct. The next thing you should do, you should find the domain of this composite logarithm, which is not gonna be very simple. So instead of finding the domain of this composite function, you better do the check, which means you look for the value of the left side for x being 3, and this is equal to log base 2 of log base 1/4 of log 9 of 3 is equal to, which means log the base 9 to the power of what is equal to 3? -2, exactly, and so on and so forth. You'll check your solution, and you will find to the conclusion that the x equal to 3 is really the correct answer. Okay, so this is logarithmic equation type of 2. Now let me go through and let me show you how to solve the logarithmic equation of type number 3, which means that we will have now logarithms with the different bases. So for these purposes I have chosen the equation which is like 2 times logarithm base 2 of x minus 3 is take away logarithm base 1 over 2 of x minus 3 is equal to 12 minus 2 times logarithm base 4 of x minus 3. As you can see, this could really look very scary, but in a little bit while you will see that this is nothing really special. But before I'll start solving this equation algebraically, I want to show you again what is the result of this equation when you solve it graphically, which means you will sketch the function on the right side as well the function on the left side, and then this is the disadvantage of solving any equation graphically if it's such a complex function, because then you would have to sketch these two graphs or these two lines, and you really have to sketch them like really properly to find where they intersect, because the black line the blue line represents the function on the left side, which is this one, f of x is equal to, okay, and the black line represents the g of x, which is the black line, and it represents the function which is defined by this equation. And basically, to solve this equation, f of x is equal to g of x, it means you are looking for the intercept of these two functions. And as you can see, the solution is x being equal to 11. So now, as I promised, this was the explanation and the graphical solution of this equation by using the artificial intelligence tool, Desmos in this case. But now let's check if the tool is really correct, and let's solve this equation algebraically. We will use the laws of logarithms in this case, and the main thing here is to look for the common base of these three bases. And the good news is that it really looks like a clever idea to use the common base, and then we will use the change of base rule for the logarithms to rearrange this equation like this: 2 times log base of 2 x minus 3 is minus, and here comes the change of base rule, so we will rearrange this one as log and base 2 of x minus 3 over logarithm base 2 of 1 over 2 is equal. Okay, so we are now using really the rule which you should be already familiar with, that log base a of x is equal to log, and it doesn't matter what kind of base you will use, of x, okay, So in the first log you use the argument, okay? You change the base, but you should use you are supposed to use the same base, log base of b, so the same base, and you write here the base from the previous logarithm. So a is becoming the argument here, okay? Now this is the rule, change of base, we used to rearrange the second logarithm or second term of the left side of our equation. Now it's a clever idea to keep 12 as the number, take away 2 times, and let's rearrange and to use the change of base rule again for this logarithm, which would mean that the numerator is log base 2, okay, because we want to have the same basis. I will highlight it later on. Now we use the argument, so x minus 3 over log base 2 of 4, okay? So here we applied the change of base rule, so from here you come to here, to this one, to this expression, okay? And now the next clever idea is to find, as you can see, there are no variables in the denominators of these two fractions, so it's a really clever idea to find the numbers for this. So it is gonna be 2 times log base 2 of x minus 3 minus, or take away if you want to, and now you really have to think about what is the log base 2 of 1 over 2. So 2 is equal to what number? And the answer is that it is equal to -1, okay? So the denominator of this fraction is gonna be -1 because of this, okay? So let me just get rid of this, minus, and it's gonna be log base 2 of x minus 3 over -1. I write it this way, and later on you will see that this is gonna be simpler. Minus 12 minus, okay, 2 times log base 2 of x minus 3, there is nothing to be done there, and 2 to the power of what is equal to 4? 2 to the power of 2 is equal to 4. Now, as you can see, these 2's will cancel each other, and this -1 is gonna change this sign to the +1. So when we do apply all the changes or all the operations, it would be something like this. Log base 2 of x minus 3. And this is all we really had to do, because now if you think about this equation, it looks like we have 2 times something plus something, take away something, okay? So it is a really clever idea to put all these somethings, or if you want to, log base 2 of x minus 3, and let's count with them like with the like terms, so that we can simplify the equation like this. 2 log 2 of x minus 3 plus log base 2 of blah 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 is 3 times, okay? Take away 1, which we will move to the right or to the left side, which is then gonna be like 4 times log base 2 of x take away 3 is equal to 12. Now you will see, and you can see probably already, that it was a really clever idea to remain 12 like the number and don't change it to logarithm base logarithm base 2 of anything, because now if we multiply the both sides by 1 over 4, it's gonna be the equation log base 2 of x minus 3 is equal to 3. And here we are again with the same thing as we started with, and as you can really notice and think about, the whole procedure or the whole goals or whatever we do with the logarithmic equations, it leads to, or we try to simplify all of them so that we can use the very basic rule, and it says 2 to the power of 3 is equal to the argument of the function, which means in this case that x minus 3 is equal to 2 to the power of 3. 2 to the power of 3 is equal to 8. So this is if and only if x is equal to 11, because we add up 3 to both sides, and then this is our solution. Let me just to check with the graphical representation of these two equations, and as you can see, really the solution is if and only if x is equal to 11. So this is our intercept of these two functions, which were defined at the very beginning as the function on the left side of this equation, which is this one, and it is supposed to be equal to the function on the right side of this equation, and this is if and only if x is equal to 11. The next thing you should do is to do the check, or in this case it's very easy to define the domain of these two functions, and the domain is defined as if and only if x minus 3 is greater than 0, which means x is greater than 3. And as our root is x equal to 11, it meets the conditions. So the conclusion is that the set of the roots, in this case it is one element set, and it is just number 11, and this is our solution. Okay, I think this was really quite complex and with a lot of explanations, and my goal was to explain you also the substitution, but I'm not gonna do this in this video. I'm gonna produce one more video where I will introduce the substitution method of solving the logarithmic equations, maybe in more details, or maybe in a couple of more than one examples. So thank you for watching, and I hope you'll find this video useful. Bye bye, and see you during our next video. Bye.